All right, we know that the sine ratio is y over r, and the cosine ratio is x over r. When r is equal to 1, then the r's kind of like go away because you're dividing by 1. So we know that y would be the sine theta, and x would be cosine theta. And these can be made into graphs. So let's make ourself a picture here. It's always easier to draw the circle first and then put the xy axis through it. So here I have the point 1, 0. Here I have the point 0, 1. This would be negative 1, 0, and 0, negative 1. Remember, I go around the circle in this direction. So I spin around the circle, and I can go around the circle infinitely many times, and I can go each way, but we're going to think about starting here and going around the circle. The first thing I'm going to do when I go around the circle is I'm going to keep track of the y values, because sine of theta is the y values. Now I'm going to put the angles in. So this would be 0, this would be pi over 2, this would be pi, 3 pi over 2, and then back to 2 pi. Okay, so there's the angles. So when I'm at 0 radians, or 0 degrees, 0 radians, my y value is 0. So the first thing I'm going to keep track of is the y values, because sine of theta is y. So y value, y value, y value, y value. And I guess I'm doing green. So from here to here, so it's 0. Okay, then the next place I'm going to go is pi over 2, and then pi, and then 3 pi over 2, and then back to 2 pi. So my trip around the circle is going to be keeping track of the y values, because sine of theta is y. So 0, my y value is 1. So I'm going to go to 1 up, I'll call that 1 up. And I go, my y value goes back to 0. Oh, my y value is negative 1. I'll call negative 1 down here somewhere. And then back to 0. So I have this y values get bigger, the y values get smaller, the y values become negative, and then they head back to 0. So think about the y values as I travel around here. The y values are getting higher, the y values are getting lower. The y values are getting more negative, and then they're heading back to 0. And this process just repeats itself over and over again. So what I always say is a sine curve is a mountain followed by a valley, and a mountain followed by a valley forever. And back this direction, it'd be a valley first, and then a mountain, and a valley and a mountain. So it goes each way forever. All right? So I'll put an arrow on there showing that it does go forever. All right. Now I'm going to keep track. So this is the graph of y is equal to sine theta. Now I'm going to keep track of the x values. So this would be x is equal to cosine theta. So I'm going to highlight these with orange, I guess. 1, 0, negative 1, and 0, back to that again. So my first x value is, it starts at 1. And then pi over 2, it goes to 0. And then at pi, it's at negative 1. And then at 3 pi over 2, it's back to 0. And then at 2 pi, to finish the trip around the circle, it's at 1. So it's a half mountain, a full valley, and a half mountain. And that just keeps going and going and going forever. Now this value here and that should be the same height. That's just my bad. All right. So if we think about a pendulum swinging back and forth, and back and forth, and back and forth. And if we drug that pendulum along the paper, we go up and down and up and down and up and down. Like a swing set, it goes out and back and out and back and out and back. So anything that's periodic, that repeats itself over and over again, typically can be modeled with a sine curve or a cosine curve. So that's the basic shape. Now we add things to it. So this is how it's going to look. It's going to be now we're going to make x our angle, and then the output of the function's y. But this is the basic shape of it here. So we say y is equal to a sine omega, and then x plus b. And then y is equal to a cosine omega x plus b. So that's the Greek letter of the alphabet, omega. All right, like it's the last letter of the alphabet, like alpha and omega. All right, so this is how we shift it and make it be different things. So A is the amplitude. So it's how high the curve gets and how low the curve gets, because you can stretch it up and stretch it down. It's a number that you multiply in front, like multiplying x squared by a number in front. So it has a little bit more meaning here. And the amplitude, it's the absolute value of A. So whatever it is, so you could have a negative number in there in front, and then the amplitude would just be the absolute value. The period is how often it repeats itself. And the period of each of these is 2 pi over omega. So that's why you need to know omega. So that's how fast it repeats itself, 2 pi over omega. And then B is just like all functions. If you add to the function or subtract from the function, it moves the curve up or down. So it goes up or down B. So B is positive, it moves the function up. If B is negative, it moves the function down. So those are all the things we can do to the sine and cosine curve. Well, we actually do a couple other things, but it's in another section. Phase shifting is kind of a pain, but this is the basics of it. All right, so my first graph here is going to be y is equal to 3 sine 2x. And it froze. There it goes. 3 sine 2x. I have no idea why this thing freezes. It's probably the stinking camera. So the amplitude is 3. So instead of going up and down to 1, it's going to go up and down to 3. So amplitude is like makes it louder if you're thinking in terms of sound like sound waves. So amplitude is going to make it be louder. So the A is equal to 3, which is the amplitude. The period, how often it repeats itself, is 2 pi over omega, which is 2. So it's going to repeat itself every pi. All right, so now we're going to make the graph. And what is the sine graph? It is a mountain followed by a valley. So instead of repeating itself in 2 pi, it's going to repeat itself every pi. So we have to make a mountain and valley before we get to pi, because it's like half the space. So there's 0, 0. I'm going to go 1, 2, 3. 1, 2, 3. Okay, so there's negative 3 and positive 3. All right, and I'm going to go over 1, 2, 3, 4 spaces, and that's going to be pi. And 1, 2, 3, 4 spaces, that's going to be 2 pi. And we go over 1, 2, 3, 4 spaces, 3 pi. 1, 2, 3, 4 spaces, that's going to be 4 pi. and then I got to make a mountain and valley squished into there. So I kind of made it be an even number. So halfway in the middle, it'll be there. There's the mountain, and then the valley should be right there. So it's going to be a mountain followed by a valley. And then there's halfway in the middle, and there's the mountain. And then down here is the valley, and then back to here, mountain followed by valley, and boom. And then we go here, and we go to there, and here, down to here. Oops, missed the dot. Small print. Mountain, valley, back to here. Up to here, to there, to there, to there. Mountain, valley, done. All right. Your calculator. We'll graph these. Yesterday I was messing around with this and I went to degree mode, so you got to be in radians. Quit. Y equals, turning the plot off down here, and I'm going to do 3 sine 2x. 3 sine 2x. Close the parentheses. All right. So I'm going to make it look just like on the paper here. I'm going to go to the window key. I'm going to go from 0 to 4 pi. So I'm going to go 4 and pi. And if I want to make it look exactly like this, and so each box was worth pi over 4. So second pi divided by 4. And then if you want to make it look exactly like this, this is 10 down and 10 up, so that you can see how it's squished with a 3. So I'll do that, negative 10 to 10, scale of 1. All right, does that look like what I have here? Hit the trace key. So if I'm at pi over 4, I should be up at 3. So pi over 4 is up at 3. So I'm in the trace mode, so I hit second pi divided by 4, boom, I'm up at 3. If I go to pi, second pi, that should take me to 0. Yep. So there's one complete cycle. And that's done. That is done. All right. Let's do another example here. So y is equal to negative cosine pi x. So there's an invisible negative 1 here, so the amplitude is the absolute value. So the absolute value of negative 1 is just 1. So it's only going to go up and down 1. But the negative in front flips it upside down, just like it would with a regular function. So instead of being a half mountain, a full valley, and a half mountain, we're going to start off, it's going to be a half valley, a full mountain, right, like so. The period is 2 pi over omega, and omega is pi, so it's 2 pi over pi, which would be equal to 2. So it repeats itself every 2. Ooh, that's weird. Instead of the pi's, it's going to repeat itself every 2. So here we go. All right, so I'm going to go 1, 2, 3, 4. This is going to be 1. 1, 2, 3, 4. This is going to be negative 1. And then it repeats itself every 2. So I'm going to go 1, 2, 3, 4. There's 1. 1, 2, 3, 4. There's 2. 1, 2, 3, 4. There's 3. 1, 2, 3, 4. There's 4. Okay, so it repeats itself every 2. So I'm going to get a whole repeat to here and a whole repeat to there. So I'm only going to graph 2 cycles of it versus, here I did 3 cycles, right? Because I did mountain and valley, mountain and valley, mountain and valley. Okay. So instead of starting up here, it's going to start down here, and it's going to repeat itself by the time it gets to 2. All right. So halfway in the middle, it should be up here, and then there, and then there, and then there. So it's a half mountain, a full valley, and a half a mountain. So normally it'd be half mountain, full valley, and half mountain. So it's between -1 and 1. Notice I changed the scale, so I'm not doing it looking in the little boxes there. So how did I know to do this? Well, I just thought about, like, you notice I counted off in 4s. So I thought about, okay, so here's the first part of it. That'd be halfway in the middle. That's the first quarter. The second quarter of it would be here. The next quarter would be here, and the next quarter of it would be there. So it'd be boom, 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 boom. Then you just do the same thing again. It would be at 0, 3, it's going to be up at 1, and then it'd be here, and then back down at 4. So it's going to go up to there, back down to here, and then to there. Beautiful. And it continues on forever. It doesn't just stop there. And again, you can type this into the calculator, and you can see if we did it correctly. So we're going to go, what was it, -1? Negative cosine second pi x, parentheses, enter, change the window. I'm going to go 0 to 4, 5, a quarter. We're going to go between -2 and 2, scale of a quarter, and graph. All right, so that looks like what we have there. And then you can hit the trace key to make sure. At 2, we're down at -1. That matches. At 1, we should be at 1. Yep. At 3, we should be at 1. So it all matchy-matchy. Yay, matchy-matchy. Now, I'm going to point something out to you here. We know that all students take calculus. Well, if you think about it, the sine curve is a mountain followed by a valley. That's quadrant 1 and 2. In quadrant 1 and 2, sine is positive. Then what happens? It changes into a valley. That's quadrant 3 and 4. Quadrant 3 and 4, sine is negative. So it matches with the quadrants. All students take calculus. First quadrant and second quadrant, it's positive. Third quadrant, fourth quadrant, sine is negative. Because sine, remember, is the y over the r. And the y values are negative down here in these quadrants. And it matches right there. Okay, so then if we go to this, what's cosine? Cosine is half mountain, full valley, followed by a half mountain. Okay, split this in half, quadrant 1, quadrant 2, quadrant 3, quadrant 4. And what do we have? All students take calculus. All the trig functions are positive in the first quadrant, so cosine is no different. It's the x over the r, so the x values are positive over here, and then negative over there. So 2 and 3, it's negative, and then 4, cosine is positive. So it all matches up. Let's see how we did for time here. So the first thing you're doing here on the homework, this is the assignment, it's in 2 parts. So it's like you do the 32 first, and then you add these on here where you're graphing. So I kind of explained it all at once. My video is going on for 18 minutes, so it's kind of a longer section to explain because it's all kind of new. So here you're determining the amplitude and the period for each one. So you just do the amplitude. Right? If there's no number in front, then it's a 1, and 2 pi over omega, all that stuff. Okay? Then this is a wonderful matching problem where you have this and you're matching it to the graph. Then on number 35, this is where you start graphing them out like I showed you. All right, well, that's the bell. 4th period's coming now. And I guess, so like, you have your amplitude there, and then omega is 1. So it's going to be, instead of a mountain and a valley, it's going to be a valley and a mountain because the negative flipped it upside down. Right? And then there's a sine curve, and then another one, another one. Oh, and then the last part of it is this here. So that just moves it up. That's the only thing you have to do. Is what I would do is I would graph this first on the graph with like real light with pencil, and then just take all the points and move them up 3. That's what that number does right there, and that'll finish it off. So you just graph this like normal, mountain, valley, twice as high, and then this 3 right here is just pushes everything up 3. So I would graph it real light in pencil. Let me show you with a pencil here. Here's a pencil, and I would just make your basic curve like so, right? And go, okay, there it is, and then just move everything up 3. So make your permanent graph go up 3. So it'd be like that. All right, peace out.